My name's Michael Baker. I work for a company called Packetloop. We're kind of pioneering in the area of full packet capture and analysis under a kind of broad term of big data security analytics. So here's the talk. I did give this talk once before at Black Hat. There's a funny story related to it. One of my friends drove all the way from Berlin to Amsterdam. And he's German, obviously. Just before the talk, he said, "Are you nervous?" And I said, "Not really." And he said, "Don't worry, none of the Europeans will understand you anyway." I didn't understand you for the first 2 weeks that I knew you. So we figured we would submit for Ruxcon and we'd have no issues with the accents. Just before we start, two of the team that I work with, two of my devs, David and Gerald, who are in the audience, they do a lot of work on the product with me, and also people who have committed to PacketPig, which I'll discuss in this presentation. So 2 basic rules is that I'm not allowed to spend too much time on the next slide, and also by about the 7.5 minute mark, you guys need to be experts in big data. So that's the only 2 rules for the conference, or for this presentation. So if we just take a brief look at the landscape, I just want to ask a general question of who in the audience is paid to actively defend corporate networks? If I can get a show of hands. Okay, so there's a fair few, right? And I suppose if any of you were at Breakpoint or the Breakpoint conference, you would have noticed that it was like one big defensive track. It was just speaker after speaker talking about how to defend networks and how to find these crafty hackers. There was people stopping pacemakers. There was an RFID-enabled, carburetor-driven knitting machine by Travis Goodspeed. I suppose what I'm trying to make the point here is that maybe some of these hackers are just smarter than us. When you contrast that to the defensive side, I was kind of sitting in the crowd thinking, can I buy a vowel? Like we were just, you look at the technology we're working with, it's 10 years old in the sense of IPS. When I was looking at all these talks around ARM exploitation, I'm thinking, well, where are the new or next 1,000 signatures for IPS that kind of specifically deal with ARM heap and stack exploits? And they're just not there. And when you look at how much exists on ARM, we can see that we've got some issues in the future. Recently, or as recent as last week, some research came out from Symantec on 0 days. I'm not sure if many of you caught it, but basically the synopsis of the research was that 0 days can exist for as long as 10 months in the wild, and that they had specific evidence of 0 days that Symantec had found. We've also got the problem, I suppose, of silent evidence, is that you never hear about 0 days that you don't detect. It's put succinctly by a friend of mine who described his sister as the marketing genius behind products you'd never heard of. So when you're thinking of silent evidence, that's a good idea. We're also faced with this problem of induction, which is also, or the problem with induction, it's also referred to as Hume's law. So if I watch a certain number of events in any given category, I can't necessarily predict future events based on those. So if any of you have read about the black swan, if you've only seen white swans, it's very, very difficult to detect black swans. And I suppose what we're faced with when you look at the caliber and the talent of people breaking into your networks, they're the prototypical black swan that is very, very difficult to predict. There's a theory that in the same way that you can't predict a break when you play pool, it's the same scenario, or you can't predict. There's a theory that the number of variables grow exponentially as you try and predict features out of any data set. But we have the ability to predict the weather to a certain degree, so maybe there's hope for us in the future. And I suppose that brings me full circle. Is big data security analytics has to deliver more than just size, speed and scale. It has to be able to answer questions that we've never been able to answer before. Otherwise, I suppose as a technology, it's kind of failed. So we take a lot of packet captures, we fire them through a lot of IPS, we do a lot of machine learning on those, and from that we try and build systems that allow us to detect back in time, find 0 days, and also try and find anomalies in our current detection systems. And here's a classic example. So Exhibit A. This was a CVE that came out last year. It was called the Apache Killer. It was covered under the Metasploit exploit you see there. Snort had a SIG for it. Unfortunately, Snort never fired on this SIG. Well, it fired for the Metasploit version of this exploit, but it never fired for every other version of this exploit. And I'm not sure if you can see the subtle difference, is that Snort was configured with this line, which allowed no spaces after a comma, and the actual attack was using a space or multiple spaces after the comma. Okay. Now, the way we picked this up was we call this a shoulder, is it was detected by a commercial IPS, but not detected by Snort. And the only way we could ever work that out is by replaying traffic. I suppose that brings me, hang on a minute. The other thing we do is we correlate different IPS. So we have an IPS in a rig and we run terabytes and terabytes of traffic through it, and we try and work out how IPSs detect and whether they are similar in their detection rates. So let's say I had 4 IPS and I ran 3 terabytes of traffic through it. You would expect that IPS would correlate very, very strongly with each other, i.e. if I found a CVE, if I found an attack, all IPS would go off. In fact, this almost never happens. The highest correlation we've ever had is 100% on the policy Yahoo webmail client chat applet. And we've never found a correlation so far greater than about 20%. So most of the time, you have correlations less than 7.5%. And that's between 3 of the top IPS you can buy and Snort, okay? Now, I'm not bagging IPS technology. Like I was talking about the problem of induction before, it's maybe the best technology we can get right now until we learn how to predict the weather, so to speak. But it brings me to a point that prevention fails. Now, you can have this conversation with people, and 5 minutes after the conversation finishes, they go back to the idea that they can prevent everything. But if you think about your budgets, you think about your layered defences, you think about everything you do in a given day if you're a defender, the fact is that on a long enough timeline, you're just going to get done. And there's just no arguing about it. You're caught up in a sucker's game. And the weird thing about that is you would think that if you knew the prevention was going to fail, if it was inherited in our language that 0 days are undetectable attacks, okay, it's pretty easy after that to understand that detection is the key. Okay, when I talk about detection, probably the best detection example, and it's so cliche now, but let's go through it anyway, it was 2011. RSA were exploited using a complex and blended attack. They detected it using full packet capture and a tool called NetWitness. And I suppose that was probably one of the highlights of what we would term as NSM technology or network security monitoring. I'm really just making the point, this probably happens every day of the week, right? All I'm saying is this is widely publicised and probably for many reasons. But there is a genre of security called network security monitoring, and one of its core tenets is probably something similar to this. So focus on providing analysts, now funnily enough, analysts are you, with the best possible information in the shortest possible time. So pretty simple, right? But it's also wrapped up in indicators and warnings, alert and detection, and I'm going to steer away from digital forensics and incident response in this talk. So advocate on detection, the idea that prevention will fail, believes in inventory to defensible networks. What we try and do with NSM is build a lot of entropy in the sense that I want to identify attacks and attackers. I know that sounds a little bit idealistic, but ultimately I want to find out who they are, and I want to be able to pick them out of traffic relatively easy, so I'm not spending all my time analysing. But one of the best things about NSM is the idea that tools collect and that people analyse. And one thing, when you're chatting in the corridors and at these kind of conferences, we've taken a back seat to the products we bought, okay? And what I'm really saying with this talk is there's the ability for us to get back into the driver's seat in the area of detection and analysis. Just start to talk about some of the tools that you can use right now for network security monitoring. These are generally viewed as like an electron microscope for digital forensics and incident response. So if you did have some packet captures, you could use these kind of tools. Obviously, Snort and Suricata aren't so much of and Bro aren't so much of a electron microscope. But certainly Network Miner, NetWitness, Squeal and Argus and FlowGrep are pretty detailed kind of tools, but ultimately it's all about context. Now, when I talk about context, I'm talking about every single bit of information I can give to the analyst as quick as possible. So not just IP addresses, not just a spreadsheet, not just a pie chart. I want to find additional intelligence on attackers. I want to be able to do branch analysis and what if. I want to be detective. I want to find out what's going on. I want it to be relatively easy. And I also want full fidelity. And when I talk about full fidelity, I don't want my logs to roll from minutes to hours, hours to days, days to months, months to years. And ultimately, over time, I lose all of that context and information that was wrapped up in those logs. I want to be able to go from 1 year to 1 minute as quickly as possible. So full packet capture, and this is, I'll talk about it in depth throughout the talk, but is a complete record of network data. Okay, so what I'm advocating here is that either for a day, an hour, a month, a year, multiple years, is that we start to record our traffic as if they were logs, okay? So the whole idea of what we do right now is we turn on all these logs get processed, they go into a seam. I'm advocating, well, let's forget the parsers, let's forget the processing of logs to a certain degree and start using full packet captures as a data source. Because it provides the highest fidelity and the greatest possible options for an analyst. You can think of it, someone succinctly put it to me the other day, that it's just like a black box on a plane, recording every single thing that happens on a network. Thanks, Chris. And we have the ability to play, pause and rewind. And I suppose there's no logging specific parsers or any device setups. This was an attempt at arithmetic that failed hopelessly, but all I'm trying to say here is that if you take network security monitoring and full packet capture, you have the greatest percentage of options, better than anything else you've got. Okay, so let's say that there was a current security incident, and funnily enough, if you go and look at the Verizon DBIR report, a couple of interesting stats there is almost, what is it, something like 90% of the time, the company is informed by a third party that they were breached, and almost no percent, I think it's less than 3%, that they detected it in their own logs. So what I'm advocating here is that using NSM-style tools and full packet capture, we have the greatest percentage of options. Now, and someone always says to me, well, you can't packet capture at this, or you can't do that, and you can't do this, but you can, right? So here's an article that came out the other day. NTOP are really pioneering in this space, and they have the ability to take 10G network interfaces, push them to disk for you to do stuff later. And that's not even going to a third party like, I won't mention them, but there's a number of obviously full packet capture solutions that can store this kind of data at line rate, okay? So Richard Baitlick, who is probably the most or the greatest proponent of network security monitoring, in one of his books in the last couple of years said, well, it's not going to be about storage in the future because, and like I just showed you a slide, the storage is not the issue. The issue is going to move from, he talks about gigabytes, and we're really talking about terabytes and petabytes, right? But how do we move from storing hundreds of gigabytes, let's just turn that into hundreds of terabytes, and make sense of it, How do we analyse that? How do we get these indicators and warnings and provide the ability to detect and respond? And that kind of brings me to big data. Now, big data is closely hitting its apotheosis of the hype cycle. It's going to go into its trough of disillusionment, and then I suppose out of that, we'll start to see some really incredible tools when it comes to security. And I think where we're at the moment is still up that ramp, towards the hype cycle. But a good example of what big data is just massively complex, structured or unstructured data sets that you want to get knowledge or data out of to make decisions, okay? I suppose big data to me was this kind of nexus of a whole series of technologies. So the nexus of cloud and elastic compute and cheap storage, the idea of being able to parallel process using MapReduce. If you couldn't write MapReduce jobs, you still had a place in this new society using Pig or Hive, which are kind of data flow languages to process. And then also looking at things like NoSQL and looking at things like Cassandra and Mongo. So these are all pretty recent technologies. Just to quickly cover MapReduce. Obviously, the data on the left is packet capture data, full packet capture data, either live off network interfaces or from data that's been stored on disk. what I want to do is be able to process that through hundreds of machines. And all the mappers do is do one simple thing, is extract keys and values. So a key might be an IP address, a value might be a count, and it passes it on to the next round. The reducers can go and combine, add, average, sort, etc. But ultimately the data that comes out is the data that I either want to persist or analyse, okay? It's not a very exciting diagram, but you have to show it if you're going to talk about MapReduce. But I suppose we can think of it as our network data, or our network is a database, and I want to ask it questions. And if you wanted to ask your network a question, what would you ask it? I suppose all I want to know is that I can scale using commodity compute as far as I can to answer the question within a period of time, and that all my packet captures are either pushed to disk or pushed to memory, and I can process that. So if you were going to ask your network a question, you've just got to think about, well, it's a 2.5 terabyte question, okay? And we just use a commodity cluster in the office. 2.5 terabyte on our 4 servers takes about 8 hours to ask a question, okay? And everyone, the sky's falling. No, it's not. If I double that, I can do it in 4 hours. If I double that, I can do it in 2 hours, et cetera, et cetera. So the beauty about MapReduce and the beauty about the tools that we're building is that if I want to answer a question on 2.5 terabytes in 15 minutes, I can. But the funny thing is, if I can't do it, there's no other technology available at the moment that can do it. So MapReduce is really the best, right? Because, and if you look at what Google and Yahoo do with it, you'll see that as well. So where am I going to get 128 compute units? Funnily enough, there's a place on the web. So just a bit of a history of these technologies. I won't go too much into this slide. So earlier this year, we built and open sourced a platform for big data security analytics called PacketPig. It was Packet, and the syntactical or data flow language we used was Pig. And really what PacketPig allowed you to do is take full packet captures, query them using a language called Pig, and then from there, the Pig jobs become MapReduce tasks that are computed or processed over a cluster. We built it so that you could either do it on premise with your own nodes, or you could do it up in Amazon's cloud, which gives you, so many nodes at your disposal. And some of the features of what we built in was the ability to have full access to every single IP packet. So anything you want, whether it's a SYN, an ACK, a SYN-ACK, if you want IP version, if you want the size, if you want the data or payload, we have full access to the packet using PacketPig. We also wrap Snort so that you can do IDS in the cloud. And we're now talking about not a live system, but obviously if I've got terabytes and terabytes of packet captures, I can run Snort anytime I like as signatures update, which was pretty important. Traffic analysis, we can also do deep packet inspection, and we've written some dissectors for HTTP and DNS. We can also do file extraction, geolocation, and Michael Zalewski's P0F was a tool that we used all the time to get additional entropy on attackers by just passively doing detection of their operating system, uptime, etc. So we wrapped that as well, which we thought was pretty cool. So these are all of the building blocks that you can kind of bring together in these MapReduce jobs. And one of the things that is relatively cool with it is the ability to find 0 days. Okay. So just give me a second here. I just want to make sure this video works perfectly on 1024 by 768. Now, all I'm doing here is showing you the PacketPig directory and the fact that I've got 2 different versions of Snort in there. Now, I can go and show you manually what the Snort detect, and which is what I'm going to do. So these signatures are separated by a fair amount of time, and I'm going to use the older feature set or signature set first. Now, I'm looking for an attack in a packet capture, and this is all happening on my workstation, okay? But what we do is we write our jobs on the workstation, then we move them to the cloud, okay? So if we just look at the alert data, I do have a series of alerts there, but none of them are particularly important, and they're certainly not the attack that I've contrived for this situation. Okay, so I'll just clear out that alert data. And then from there, I'm going to run snort again, but this time you notice I change the snort signature set. So now I'm working with the most recent signature set at this time, and again, I'm going to reprocess the packet capture. Now again, this is not packet pig, and this is not in the cloud. This is just normal snort with a -R. But you see when I use the alert up the top there, I've now got a recent Oracle JRE bug, which was rated as priority high. It was used by all sorts of people. It was the one that Oracle said they weren't going to patch for months. And I've now detected a 0 day, effectively. I also get the 4 tuple of the source and the destination, how it happened, and also the priority there. If I just go through the job, you get a bit of an idea of what pig looked like. So you can kind of see it's a reasonably verbose and relatively basic language where I've just given it some variables of the old snort and the new snort. I'm going to look at my old snort alerts, and there's the schema of time, stamp, sig, priority, message, etc., protocol, source, source port, dest port. And then from there, lower down, I've got the snort new alerts. And then, as you'd expect, I minus the new from the old and gives me 0 days. I'm just going through the logic down the bottom there. Now, when it outputs the 0 days, I can either just put that to a text file, or I can also, this is the pig job now. So the pig job just takes that job that I just said, and because it's Java, there's like 1 billion lines of verbose output. But as I said, this is the kind of experiment you run on your laptop, and then when you're ready to move it to your move it to the cloud or move it to your on-premise cluster, you can. Okay, I'm just going to check the output of the pig job, and you can see that the way we've built it is it's almost identical to the output that we were getting from snort. Okay, and down the bottom here, I've got 2 attacks. I've got their timestamps, signatures, the Oracle Java privileged escalation bug, and the source and destination. And I can do this for anything, right? I've just built this scenario so it's easy to demo, but you can run this at any time on any amount of information. So the next thing I want to show you is, and hopefully the screen res works for me, is I take that same job, and I'm going to move it to the cloud. It's not too bad, but it's not too good either. Okay, that's terrible. You know, I recut all my videos last night at 1024 by 768, but this is the one video I couldn't cut. All I want to show you here is that number says 585 gigabyte, okay? And this is a series of packet captures we've been taking in the cloud, where we've been outputting every single minute of every single hour of traffic. I'm going to kill that. Okay, so finding 0 days. Now, that, I suppose you start to think about, okay, well, that's pretty interesting. You can do that on lots and lots of data. You know, what does it give you? Well, I think it's worth a JD. It gives you the motivation of the attacker. So I can see how often they're trying, who they are in the sense of, you know, what ISPs, what latitude and longitude, are they obfuscating? Are they sitting behind a proxy? Are they using Tor? How often are they attacking? Are they using different attack types? What are their time windows, etc. So yes, finding information in past data, it does give you a huge amount of information. Now, I'll move on. So because that job, I used 80 nodes, the 600 gig. I used 80 nodes in Amazon at about the 9 or 10 cent mark. So I couldn't make it a cup of coffee anymore because it was about $8. So to go through that 600 gig, it cost me about $8, so I put it to a kind of price of JD. Okay, the other thing that we can do is we can pivot off any bit of information that we get to find more information, okay? And a good example is, let's say that I had, for every person that attacked me that was a high severity attack, I wanted to go back through every single connection they ever did, or every single file they ever sent, or every single file I ever sent them. You can do that with big data. And one of the things I'll show you is an attacker information demo. Okay, so that should fit nice. So again, I'll just run you through the pig file. What I'm using here is the HTTP conversation loader because I want to grab the user agent. The next one is the snort loader because I want to grab all of the attacks. Let me just make that full screen. And down the bottom here, the last one I want to show you is P0F, okay, where I want to get your fingerprint. So what I've basically done with PacketPig is I've said, I've mixed all these building blocks together to give me a lot of information about attackers. And I'll go through some of the logic. Okay, so it starts down here. So where you see high severity, I'm firstly filtering all of the alerts by severity equals 1, okay? And then for all of the high severity alerts, I want to generate the for tuple, and I want to use the for tuple using, and in this case it's MaxMind's GeoIP database, to get the country, the city, and the latitude and longitude of the attacker that just caused a severity 1, yeah? Now, after that, I go and do some grouping, and I want to go and group the high severity attackers. I want their fingerprint, I want their HTTP, and I want their location, and I want to output the summary, okay? So the ability I have here that you don't have, I suppose, currently, is if you're using log data, you would have blinked and you would have missed it, okay? You wouldn't have any ability to go back and gain any additional entropy on the attacker. I'll talk about entropy a little bit later. Okay, so what does it look like? Sorry, typing and looking different. Okay, and this is just an example of what I get. So on the very left-hand side, I get the snort sig, I get the attack type, I also get the user agent, I can compare the user agent to the fingerprint, and I've got operating system, user agent, source IP address, destination, latitude, longitude, and city, just out of that. The other thing that's nice is do file extraction. And you might be doing file extraction for malware analysis, or you might be doing file extraction just to see every single file that exits your network with every single MD5, SHA-1 or SHA-256 hash that you can possibly produce across those files. So I'll give you a quick demo of the file extraction. Give me a moment. Now this one I did do in 1024 for your pleasure. Okay, so again, wow, I'm using PacketPig, that's excellent. I'm just going to show you the example that we've got up there for extracting files. Now, I can either download the files or just produce the hash. If I put a path in there, it'll push all of the files and actually extract them. I can select different MIME types if I only want to look for particular files, but here I've left MIME type blank so that I can extract everything. Now, what it then does is use the conversation file loader and gives me timestamp, source, for tuple, the file type. We wrap libmagic so you can get the file type out of it. And it'll actually look inside zips and gzips and tars as well. And then from there I get the MIME type, the extension, the MD5, the SHA-1, the SHA-256, etc. Now, why would I be looking for hashes here? Like, if you go and produce 1 billion hashes, you might only have a couple of 100,000 that are distinct. And if you wanted to take those 100,000 and push them to something like virus total, you could. Well, I'm not sure now that they've been bought by Google, but you used to be able to do this, right? So if you wanted to go and compare a billion hashes, and you could create a billion hashes, that's not insurmountable, right? So then I can quickly just see, okay, well, out of those billion hashes, how many of those are weird? Or how many of those are bad on virus total? The other thing you might be looking for is you might have lost a file, or someone has sent a file that they shouldn't have. And you want to go and look at, okay, well, the hash of that file is X. Why don't we go and compare that and search for the hash across the last 1 month of full packet captures. And this is what the conversation file loader gives you the ability to do. I think I covered all that. So what does it look like? Wait. Okay, just give me a second. Now, I'm just going to show you the output. Actually. I'll just stick with the video for a second. So again, that's the wrong video. I'm just going to run this job. Please play. So you can see the output. Now, what I did with this one is I just went and browsed Sydney Morning Herald, and I took a full packet capture of it. And then when I run this job against the Sydney Morning Herald capture, every single script, MIME type, file type, etc., is all extracted. And I also get I get two outputs. I can go and look at the files themselves. So this is the text version of what you get, and what you can see is basically the schema I just showed you in Packetpig. It also shows me every conversation for tuple that went out on, so I know that this happened on port 80. Like I said, we wrap libmagic, so you can see some additional information. You'll see that down here when I start to look at JPEG data or JFIF standards. Now, I haven't really done a malware bent here, but it could easily be a malware bent that you're looking for. And GIFs and JPEGs. The other nice thing is if you are actually looking to dump traffic, you can quickly dump it. And I'm just going to show you the temp directory. Now, the reason why I keep the hash there at the moment is just for our internal use, but you can actually see the file name is the very last criteria. You can sort by file size or sort by image type. Generally, images are the best things to look for on networks. These are all safe, but as you'd expect, never always safe. And I was actually going to test this demo a bit further. Gerald, one of our guys, gave me a packet capture, but I was going to show you the output, but I'm now not as confident as I was when I started the talk. And I think I need to hurry up. Okay, so big data security analytics. I know it's got big data in there, so instantly you take offense to it potentially, or think that I'm some kind of charlatan, but I'll give you some basics. Okay, I want to explore and I want to analyze. And I also want to explain and present, okay? But ultimately what we want is knowledge from data. Has anyone seen this before, Anscom's quartet? Okay, I'll just take a little bit to explain it. There's 4 data sets at the top there with Roman numerals. Each one of them has an X and a Y coordinate, let's say, or X and a Y value. Now, each one of these X and Ys for each one of these data sets has almost the identical variance, standard deviation, average, sum, etc., right? So when you look at this, these data sets look identical. And if you were to chuck this in Excel, and like I said, do the variance, standard deviation, average, sum, etc., they look identical, okay? But as soon as you graph them, they're totally different, okay? And Anscom's quartet is effectively what I'm trying to say about our current level of, I suppose, ability to detect and respond. Is if we're looking at Wireshark, if we're looking at these electron microscopes, we don't see the information that's in the data. You know, you hear a lot about how humans are the best pattern matching machines in the world, and I suppose all we're looking at doing is kind of giving you a platform or a way to look at that. So here's my handy kind of grab bag of what big data security analytics is. It's heavy on visualization. Okay, so instead of giving you a pie chart, it's trying to give you a lot more information and data that you can make decisions on. It's full fidelity, and instead I'm talking about data fidelity. So there's no abstraction. Okay, I'm not rolling days into months, months into years. I'm giving you every single thing I possibly can. You can interact with it. You can play, pause, and rewind. It's got to be able to do quick and easy outlier detection, attacker profiling. I need to be able to enrich the data with latitude and longitude, or build network graphs similar to what you might have experienced with Multigo. I need to be able to predict and get probabilities. I need to be able to share intelligence or share metrics. And I need to be able to do feature extraction, but the crowning part of it is machine learning, and I'll go into that in a bit. So this is not SIEM, okay, and it's not even SIEM 2.0. It's not even close to SIEM. It's seamless, you know, in the sense. And what I mean by that is SIEMs, because they use relational database technology and they only operate on logs, they don't have full fidelity, okay? Ultimately, they abstract you. A correlation in a SIEM is a join on a key, okay? They don't allow you generally to explore and explain the data, okay? And I don't have the ability to branch analysis. I don't have the ability to go back. I don't have the ability to find new information out of the old information because I'm working off logs. I'm not working off full packet captures. I kind of refer to it as blink and you miss it technology. You know, if you're not there, if you weren't there, you didn't see it, it's gone. Once that event has passed, you can't go back and extract any more information out of it. So I suppose what we're really talking about here is intelligence as part of analytics. Okay, so one of the key areas there I spent was visualization. I just want to give you a quick demo of this, okay? So this is full HD, play, pause, and rewind. So no more text, okay? I can tell that you're over it. And this is just going to fit on 104 by... please fit. Okay, now we're really pushing it. We need, while we're doing big data security analytics, can someone build a high-def projector? Okay. Okay, so this is a classic data set. It's called the DARPA 98 data set, and you've probably never seen it like this before, or hopefully you haven't, otherwise I haven't done my job correctly. Don't worry about the legend down the bottom on the left. That's just the order of me shrinking it. That better or that? That one? Scroll down a bit. Oh, no. Sorry, you have to work with me. I need at least a little bit to play with. Okay, so that's 3 months of data from end to end, okay? Now, you can just see this is August, you can just see this is June, and the bars here are sorted by the dark is a high level alert, the medium blue is a medium level alert, and the light blue is a light or low alert. Now, there's a specific reason why I haven't chosen yellow, green, and red, okay? And I may or may not cover that in this talk. Now, what I was talking about before is I want to go from 3 months to, let's just track these dark blue bars, which is something I'm kind of drawn to. And you can kind of see that with no loss, I'm drilling in and drilling in and drilling in and drilling in. And now we're at the, where are we at? The 1 hour, 3 hour mark. And then I want to keep going in. And that actual bar is not one bar, it's lots of bars. So as I get down to the 1 minute, I've got a kind of really good view of what the hell is going on, okay? So 3 months, 1 minute, okay? 1 year, 4 years, 1 minute, okay? That's the idea, and that's one of the things that big data can solve. Another thing that big data will generally want to do, or I shouldn't talk about big data in the third person, it makes me sound really, really strange. Okay, so let's just move to, now I don't want to look at the data based upon severity, I want to look at the data based upon attack types. And what I've done here is we've encoded each one of these colours as a different attack, and the height of the bar is the frequency of the attack. Now in DARPA 98 there's a very, very small number of attacks, but it's a really good visualisation. Again, I can drill in and in and in and in and in until I get down to the minute mark, and instead of me losing everything, I'm getting everything, right? I'm seeing everything that I want to see bundled up in this visualization, okay? So that's the idea of full HD play, pause, and rewind. Now, one thing that I just want to show quickly, I can play around with some of this if you want me to. I might not react well to stacked bars. You might be a kind of area guy, or you might be a stacked area guy, or you might be a line guy, or you might be a bubble chart guy, okay? Now, the interesting thing about scatter plots is when you annotate them, all these scatter plots I'm showing you now are giving you a bubble based upon a certain subset of information, which you may or may not want to change. So down the bottom here, the bubble is built by your average severity. The Y field or Y axis is the number of attacks. The radius is the distinct number of attacks. So the bigger the ball is, the more attack types you've tried against me. So generally, no, I don't want to say this. If you're in the top right and you're a big scatter, then you're a problem, okay? And I'll just close the controls. Now, same kind of thing. I want to be able to move in and see how these things change, okay? And I might just also want to highlight one of these balls, and then I might want to move left and right and see how they move and change. Now, why am I doing this? I'm trying to see whether there's different things that are important. I'm trying to see whether there's a way to explore and explain the data. You know, why is that guy there? And why is that guy there? And why is there no one over here? Because this would be a high severity area. Anyone up in this quadrant is worry. And sometimes you just don't see the information until you get it to move. Okay? And you can see attackers start off slow with low severity attacks. Their circles start to grow. They sometimes move to the right. And they were the kind of things I'd like to trigger. Okay? They're the kind of things that if I was looking at the last hour of activity, they're the kind of things I'd like to explore and explain. I can leave that going. Should I? No. I'm trying to get perfect demos, so it's best not to play around. Okay, outlier detection. As soon as you get into outlier detection, you have to do feature extraction. Now, we don't do a lot of feature extraction in security or in our network security, but funnily enough, Michael Zalewski's P0F tool is a feature extractor. And I'll just show you a couple of things. So, one thing that that network traffic responds quite well to is the extraction of features. Now, I'm not sure if you've seen some talks recently, certainly there was a lot last year, where people were taking the average packet size and inter-packet delay and using things to classify it. And someone will know this, the guy that gave the talk at the Chaos Computer Conference, where he effectively decoded Skype by using mainly packet size and inter-packet delay. Okay. Now, what I've done here is I've taken two captures. Okay. The first one is these are both from the same network, and what I've done is T1 means I've trained off this capture, and T2 means I'm testing this capture. Now, just with some basic machine learning and using linear regression, I was able to get 1,537 hits out of 1,546 packets. Now, I'm using 21 features here. Okay. So the ones that I've outputted there are the ones that I got wrong. So what I'm trying to say here is that big data, feature extraction, used to process machine learning is an excellent example of what we can use for classification. Now, why would I want to classify? I may want to train on HTTPS and test Tor. I may want to train on DNS and test interpreted DNS backchannel. Okay, and I want them to fall out of the data straight away. By the way, that's 99.6% correct. Here's just a different scatter plot. And it's not full of awesome, but it's kind of a little bit awesome. in the sense that I've just taken 4 protocols here, I've extracted 21 features and I've just plotted them using principal component analysis or dimension reduction. So instead of having 21 dimensions of data, I just want 2, and then I want to be able to look at the protocols from there. And you can see in this plot, not so much for the protocols other than TCP80, but you do see a lot of variation in port 80 and a lot of variation in TCP. So moving out of feature extraction, why is it important? Well, it's important for novelty and outliers, okay? And I'll just give you a definition of both, okay? So novelty is when our training data is not polluted with outliers. So it's kind of like a sanitized training data. I can then take the novelty of that data, I can take that data and test new transactions and say how novel they are or whether they're interesting or not. The other thing is outliers. I have a data set that's polluted with all sorts of different crud, and I want to be able to choose what's good or what's bad out of that. And I gave you an example of HTTPS versus Tor before, and you can kind of get a plot like this. Now, I'm not going to go into it too much because it's kind of a subject of a different talk, but all I've done is the inliers are on the left, the outliers on the right. I've got a whole series of traffic that's on port 443, and all I want to do is drop out the 2 Tor connections that I've got. You can just see that on the right. This has a lot of benefits for entropy and covert channels, okay? It has a lot of benefits for building entropy in the sense that working out how interesting something is, but also for identifying covert channels and back channels. We do a lot of work looking at Meterpreter, but there's obviously a million others in it. Okay, enrichment. Kind of 3 things I want to cover here. Geocoding, Tor, and torrent triangulation. Okay. And I'm going to show it to you in a video. Please, full screen. Okay, so just give this a portion to start up, and then I'll start the talk. We'll just edit this video later. Just want everything to go black, and we'll start from here. Okay, so this is a real data set from a customer, which has 1 million attacks in a 12-day period. The data set was around 3 terabyte, okay? So they gave us full packet captures for a 12-day period, and what we did is we went and transposed all of those into latitudes and longitudes, and then built you a visualization. You won't hazard to guess that, also you can play around with this visualization later, and I'll tell you how, with your own data if you want. Okay, so this is what an average day looks like. You can look at the timescale down the right here. Red is high severity, orange, medium severity, yellow, low severity. Now, this is not so interesting maybe for yourself, or maybe it is, but certainly maybe for your boss, or maybe looking at trends over time, or looking at anything other than attack data. It might be files transferred. If I wanted to plot every single Word document that left your network on plain text, HTTP, or SMTP, etc., and I wanted to know where the hell it was going, if I wanted to look at DNS queries or rates of DNS queries, if I wanted to look at transactions and why they're coming out of particular countries when we don't have any customers there, this is the kind of visualization that I think allows you geographically to see this information. The other thing I love about map visualizations is it makes it personal. For some reason, it's no longer an Excel spreadsheet. I want to know why that guy's doing that. Actually, you can see a lot of attacks just pop up straight out of Melbourne and come up and then go straight into Sydney, okay? And Sydney also has another, there's 2D view. And you can kind of see the same things here. If I speed it up, the sun actually traverses the Earth. Anyway, I'm going to leave that on as long as I can, so that, because there's a lot of work and effort and that went into it. One more, give me one more. Okay. Now, where it becomes interesting is when you start to put other things on the map, okay? So, I'll just kill that. And what we've been doing for a period of time and has been tracking about the top 1,000 files on a particular public tracker for BitTorrent. How do I do that now? That went the wrong way. Now I lost it. And also tracking the Tor nodes themselves. Oh man, this is killing me. I've got it. So this time the little onions are Tor nodes, and we can use those little onions. Oh, also the attack data is DARPA 98, so nowhere near as rich. This is 20 years ago, right? 20 years ago, people didn't attack each other. These days, the globe lights up like a Christmas tree. But this viz also allows me to track what attacks are coming from Tor nodes, and also I can then go through the Tor nodes, or through the attack, sorry, to the Tor node or to the BitTorrent. And one of the things we demoed at Black Hat was the ability to track people through their BitTorrent progress. So you attacked me, I know all the IPs from a public tracker, I know the percentage at which all of those people are downloading a particular file, and at such and such a percent you attacked me, and later on you viewed my website and you were at X percent, okay? So it allowed us to watch people who were moving between different IP addresses, and also allowed me to track people that were using Tor. And I'm just showing you here that using OpenStreetMaps, we can also drill down. Now, do I think you're going to apprehend an attacker using this method? No. It's not really about that. What it's really about is giving you as much information as possible. Right. We can transform this information into network graphs, and you're going to see a whole series of pre-computed Multigo S-style interfaces and visualizations that you can drill into and drill out of. The area in this is a lot of the work that will go into this area will be quite beneficial. Intelligence and metrics sharing. A couple of standards kind of coming out, and some of you may Google, but anyway, the open indicators of compromise is a kind of standard put forward by Mandiant for tracking down network and host-based indicators of compromise. There's also a kind of other standard called Cybox, but as soon as I saw XML, I just really switched off. So what we kind of thought was, well, shouldn't I just be kind of forking a GitHub repo, writing some kind of packet pig style analysis and queries, and then just executing that across a sample set of data? And couldn't we get a whole heap of people to collaborate on the kind of things that are important? And that won't be a way for me to kind of do this indicators of compromise. And a good example is DNS and malware. I'm just looking for fast flux domains in this example. So really simple. I go and process a data set. I couldn't put too many domains on it because only so many will fit on the page. But really all I'm looking for is traversal. Okay. Now the only one here that we can kind of see is moving along the TTL timeline is one that's from Akamai that I'm pretty happy that that's okay. But of course, if I saw large amounts of queries, small amounts of queries, if I saw you responding to a CNAME query with lots of hosts from lots of different countries, if I saw you moving TTLs very, very quickly, if I saw you querying weird kind of names, then I can kind of look at things like, are you a DNS back channel, etc. So we always kind of end the talk with a kind of ominous, kind of analytics or surveillance. And I don't know why I do it, but I always do. It's a really good article, and the bit.ly link's down the bottom there, of Big Brother on a budget. Whenever you take big data, vast amounts of data, quantities, etc., and the ability to process it cheaply, there's always going to be nefarious types that are using that. Now, I don't really want to get caught up in the data retention law debate, but all I'm saying is we should be very, very careful of this. Yeah. But a really good article if you want to take the time to read it. Okay. Questions?